Hello, this is Tyler and this is my 8Puzzle solver program. So, the interface is pretty simple. You just select which algorithm you want to use and you select which puzzle you want to use, click solve. The output for the solution is here. It shows you the steps taken, how many steps, and like the amount of time and cost. You can copy output, pretty handy. Different ones. Oh, I accidentally halted that. So you can like stop execution if it's taking too long. For the code, the main like powerhouse of this whole project is the puzzle state class. This is just every node is like a puzzle state object, and each puzzle state object keeps track of its parent node. It keeps track of the board, which is just an array representation of the game board. It keeps track of the cost to that node, the total cost of the path so far. It keeps track of which direction it came from, but it also keeps track of the heuristic. And this isn't heuristic's a little bit of a poor name for this, I suppose, but this is just like telling it how to calculate the f value, or like the f of n. So like for each different algorithm, it can set what it's going to use, and then it will store that value in this variable f here. Now the big thing that I did with this is instead of having the algorithms keep track of which nodes have been visited, I did that in the puzzle state. So each puzzle state has a reference to this common visited like hash map, and this will keep track of which nodes have been visited. So, each to the successor function get moves, we'll get all of the successors. I just call them moves. And it will just find from the position like what horizontal moves it can make, what vertical moves it can make, and it will call this function new move, which creates a new puzzle state. And it will call the function has visited and check if that puzzle state has been found before it like does anything else. And it will go through this array visited and not just check if it's been visited before, but also check if the f value is lower than the f value that's saved in the visited. So if you go to the same node again, but the f of n is lower, it will still go to that node, and it will update that. So for the algorithms, they're pretty straightforward since the puzzle state takes care of most of that stuff. Like breadth first search uses a queue, and it pops off the queue. It checks if it's the goal, prints the solution if it is, and if it's not, it just adds the successors. Depth first search uses a stack instead, and I should mention this stuff is just like for the statistics at the end for how the queue is being used. Yeah, but otherwise the loop's pretty much the same. Greedy best first search is a bit different. It uses a priority queue instead, and it sets the heuristic of the puzzle state to using just the correct tiles, so that the puzzle state knows to use this function compare to compare the f of n values when using the priority queue. So then it goes through them, it gets them the minimum value automatically using the priority queue Java class. And yeah, pretty much the same. All these are pretty much the same as greedy best first search, except that they change which heuristic is used. So this one just uniform cost search sets the heuristic to cost. The first A star sets it to cost plus correct tiles. A star 2 is cost plus the sum of the Manhattan distances of what tiles are incorrect. So yeah, that's pretty much it. Thank you.